My name is Alan Pickering. I'm doing a short video on my latest hot air engine. I started this around about November 2017. It took me 1.5 months to finish. It's all made out of scraps out of this workshop. The flywheel was the only bought thing. It came off eBay, it was £20, and it's quite a nice flywheel, and that's what got me started really. You can see the spokes are quite pleasing to look at. Not very often you see it like that. I've just had this running for about 20 seconds and it should start. There we go. It's quite an unusual design. Lots to see. This is a Villiers 9E 2-stroke crankshaft. I've had it for about 100 years in the scrap box. I used one once before to make a Freelance Hot Air Engine, which was very good, but it was a bit greedy on fuel, because I had no water cooling or heat sink on it. This one, I wouldn't advise anybody to do it, because the crankshafts are glass hard and impossible to machine. You need a cylindrical grinder on the job. Not having one, I put it in the lathe and I managed to take about a 1/16 off it. It's a tapered shaft, but it took me all day to do about 2 inches. 2 thou at a time. It pushed the tool away and had to be reground for every cut. A horrendous job. And it's reasonably true now, but not a job for the faint-hearted. These pillars that you see are a bit extravagant. They're silver steel. I've had them in the workshop for about 100 years, and I decided now's the time to use them for something, because they're useless for anything else. So I turned them into 2 pillars. I've got a little generator down here, a little Stewart dynamo. It's only for show really. It should do 8,000 RPM and give you a few volts. In actual fact it gives me about half a volt at this speed, whatever this is. I should think about 100 RPM, something like that. There's universal joints on here. Built to a very high precision with bearings in everything that moves. Even these little things in here have got bearings in them. There's a gland in there which you don't need to tighten. Top and bottom plates are 1/8" steel plate. The burner itself is something I got off a camping stove, and it's the hot air cylinder is a kitchen utensil about the right size. It goes right up to the top, and the displacer inside it is a sugar basin of stainless steel with a top welded on it. There's about an 1/8" clearance around them to allow the hot air to escape and get up to the power piston through this little copper pipe you see here. The first 1.5 inches of the cylinder is solid steel. The rest of it, it's got this Villiers 9E piston with soft packing, and it's got a stroke of 2¼ inches. The cylinder is made of cast iron or meionite, I don't know which, but it felt like cast iron, and it was very, very dirty. When I'd finished it, it wouldn't work, and it was because I'd put oil in the cylinder. When I took it down, cleaned it, away it went. I've got the phase difference going at 110 degrees. I've also put graphite powder in the power cylinder, which has made quite a nice job of it. It's well pleased about that. What you see on the top is a big heat sink. It's got no fins on it, but I did a few little experiments, and this was a big chunk of metal, half-inch thick, and it's heavy. And underneath is a half-inch square gland of asbestos packing to try and keep the flame from heating it. Also, this is a piece of gauge plate that stops the flames licking round the edge. You can see the cylinder head on there with about 8 Allen screws in it and a gasket. Just wander around, let you see what's going on. They don't have an awful lot of power, these engines. If you want power out of a hot air engine, you've just got to make it very big. The last one I had, I took a video of it in this workshop under the same conditions. It had double the stroke, nearly 3 times the size. It was more powerful, and there was an awful lot to see going on. Quite a unique design. This one is a unique design. That's why I built it. I like to see things moving about. Let me turn the pressure down if I can get past this. It's a bit difficult to keep the camera still in a small workshop. Turn this down, let's get not too much gas left actually. But these stainless steel sugar basins are quite useful things. In fact, I've started collecting them now. There's one up there. There it is on the shelf, waiting to be turned into an engine, no doubt, one day. There we are, going a bit slower. They've got to be made friction free, and that's difficult to do. You've got to have bearings in everything, and you've got to make it dead accurate as far as alignment is concerned. It's very, very heavy. I can only just lift it. I even take the burner out because that's heavy, just to make it liftable for me. Everything I make tends to get heavy, I don't know why, but I just don't seem to be able to make anything small. Very hypnotic. A lovely little showpiece to take round and show people. I'll have them both running on the bench this year at various shows, hopefully. I say the whole thing has probably been built for 20 quid really. There's not too much you can build in the model engineering line for that sort of money. I recommend these lifting tables to anybody building things like this. They're ever so useful. They're also good for putting underneath the bench for taking out big heavy drawers full of steel, like so. Just put them under one of these drawers, pull it out, and you don't finish up with everything on the floor. There's 4 columns holding the top plate on. 2 big ones and 2 small ones. I've had this running for about 4 hours. It's not got water cooling, which will be nice, but water cooling makes things very difficult. You've got to have a big water tower, you've got to have a water jacket, you've got to have a water pump, and it makes the engine twice as big and a little bit more trouble to run and steam up and get away again. You know, all the water's got to be filled up and drained, etc., and cleaned. But it doesn't seem to be any worse off for being air cooled. And I say there's no fins on the thing. It takes an awful lot of heat to heat a great big chunk of steel like that. I say it's 1/2 inch thick, and it takes a lot of warming. And compared to the bottom stainless steel bit, which is glowing red, there is quite a difference, and that's what's giving you the power. When I finished the engine, it wouldn't work because I'd oiled the cylinder. There's graphite packing in there. I cleaned it, put some graphite powder in the cylinder, and away it went. And if I squirt it now with WD-40 or anything like that, it just stops dead. It turns into glue and won't go round. I've never understood that. The last engine I had a monometal cylinder, and that required oil. This is quite an hypnotic little engine. It makes a good little ornament in my lounge and a wonderful doorstop. All the flat surfaces have been surface ground. I've got a little surface grinder here, which everything goes on. If I can get up, I'll show it to you. Round we go, slowly, slowly, slowly. There it is, living in the corner there. What a lovely little machine, and it just swings about like that. Grinds everything lovely and nice. Very compact layout. Let's see if I can squeeze past this vice. Yes, if you visit my website, just tap in Alan Pickering history. You'll see lots of engines I've made, steam and hot air, and there's videos there of stuff that's like this, up and running. Or www.tradjazzband.co.uk, and the second from the last page, it's all on there. This is Alan Pickering, signing off.